Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about simplifying rational exponents.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, n to the fourth power, all to the 3/2 power, and we got to simplify this. Well, first thing we know with our rules is that when we have this n to the fourth all to the 3/2 power, we multiply the exponents. So we have n now to the 4 times, well, 3/2. Simplify that. Well, that's n to the 4 times 3/2. We multiply the numerator. 4 times 3 is 12. So we have 12 over 2. Well, 12 over 2 we can, simplify as well. What's 12 divided by 2? But 6. So we have n to the 6th power, and that's it. That is our final answer. We're given this problem right here, 27p to the 6th power, all to the 5/3 power, and we need to simplify. Well, this 5/3 power needs to be distributed to both parts here. Remember, that's 27 times p to the 6th. So what does that look like? Well, we'd have 27 here to the 5/3 power times, and now we have p to the 6th, right? And we multiply the exponents. So 6 times 5/3 is going to be shown as like 6 times 5 over 3. That makes it easier. So then from here, how can we simplify? Let's move down. Well, 27 to the 5/3 power is the same thing as the third root of 27 all to the 5th power. It's kind of good to know our rules there. Simplify the right one, p to the 6 times 5 being 30 over 3. Now let's keep going. What's the third root of 27? Well, third root of 27 is 3. So we have 3 here, all to the 5th power, times, well, 30 divided by 3 is going to be a 10. So we have p to the 10th power. We're almost done. 3 to the 5th power is, well, it comes out to be 243. And we bring down p to the 10th power, and that's it. We can't simplify this anymore. So our final answer is 243p to the 10th power. We're given this problem right here, 25b to the 6th power, all to the negative 1.5 power, and we got to simplify. Well, let's go write this instead of a negative 1.5 power, but to a negative 3/2. I kind of like dealing with fractions here. So we have 25b to the 6th, all to the negative, well, 3/2 power here, okay? Now our rules with exponents, for multiplying that out, we're distributing essentially to both parts here, this being multiplied. So to do that, we have 25 to the negative 3/2 power times b, make sure I don't lose my place here, b to the 6 gets multiplied by the negative 3/2, and so it's 6 times a negative 3/2 like this, and that's all to the power. Well, how can we simplify this? Well, a negative exponent means it goes down to the denominator. Okay, so we're going to have 1 over, and 25 is going to be here, and that makes out the positive 3/2. Now, we're going to take the 1/2, the 2 down here, equates to the square root, and then all that to the 3rd power. Hopefully you can see that, right? Square root is the 1/2, and the 3rd power right there. Negative brought it down. Multiplied by. We'll simplify here. 6 times negative 3 is a negative 18. And we still have over 2. Well, keep going here. Square root of 25 is 5. So we have 1 over 5 to the 3rd power times, and then, well, hopefully we can kill 2 birds with 1 stone here. Negative 18 over 2 is a negative, 9. Then we can put this as 1 over b to the positive 9th power. All right. Lastly, let's go multiply all this out. We have 1 over, all one big thing, multiplied it out. Well, 5 to the 3rd power is 125. And then we just have b to the 9th power. And so my final answer here is 1 over 125, b to the 9th power. We're given this problem right here, 64 times m to the 4th power, all to the 3/2 power, and we need to simplify. Well, we know here, when we have an exponent, we can distribute it essentially to both parts, this being separated by multiplication. So this is really 64 to the 3/2 power times m, and we have our exponents, right? 4 raised to the 3 halves power, we multiplied those exponents. So it's going to be 4 times 3 over 2. Then from there, we're still going to keep simplifying. 64 to the 3 halves power is the same thing as the square root of 64 all to the 3rd power. Remember, the square root is equal to the 1/2 power. Times m here. Let's simplify this. 4 times 3 is 12, so we have 12 halves. Well, the square root of 64, okay, square root of 64 is 8, and then we put that to the 3rd power, and that comes out to be a 512 here. And then 12 divided by 2 is a 6. So we have m to the 6th power. And so that's actually it right here. Our final answer is 512 m to the 6th power. We're given this problem right here, a to the 8th power all to the 3 halves power, and we got to simplify. Well, we know our rules of exponents here is when we have something here raised to a power, all of it raised to another power, we multiply the exponents. So this really is a to the 8 times, 3 halves. Well, we know we multiply across the numerator, right? This is really 8 over 1. And so 8 times 3 is that 24. So we have a to the 24th power over 2. Now, 24 divided by 2 isn't too bad. Let's go move down here. 24 divided by 2 is a 12. And that's it. Our final answer here is just a to the 12th power. We're given this problem right here, 9r to the 4th power, all to the 0.5 power, and we got to simplify. Well, I don't really like having a decimal there, not all the time. So I'm going to rewrite this to be 9r to the 4th power, but instead of 0.5, I'm going to write 1/2 in fraction form. So now from here, well, we know we can distribute the 1/2 to both exponents. So 9 here is really when we distribute that, multiply it out, it's just to the 1/2 power. R is going to be that 4th power, but when we distribute the 1/2, we multiply the exponents here. So we have 9 to the 1/2 times r to the 4 times 1/2. Well, 9 to the 1/2 power is the same thing as the square root of 9. Our 4 times 1/2, well, 4 times 1/2 is just 2. So we have r squared here. Keep on going. Square root of 9 is 3. And we have 3r squared. And so our final answer here is just 3r squared. We're given this problem right here, 81x to the 12th power, all to the 1.25 power. And we got to simplify. First thing is I'm going to convert 1.25 to a fraction. So to do that, we have 81x to the 12th power in our parenthesis here. But instead of 1.25, that as a fraction is 5/4. We now can distribute this 5/4 to both parts. Multiplication is separating the 81 and the x squared. So to do that, we have 81 now to the 5/4 power times x to the 12 times the 5/4 power. Remember, we multiply the exponents here. Simplify a little bit here. 81 to the 5/4 power is the same thing as the 4th root of 81 all to the 5th power, if you remember your rules. Well, 12 times 5, we're multiplying this out here, so 12 times 5 is that 60, so we have x to the 60th power over 4. Keep on simplifying here. 4th root of 81 comes out to be a good old 3, still to the 5th power, but 60 divided by 4 is 15, so we have x to the 15th power. Almost done. 3 to the 5th power is 243, and we have x to the 15th power right here. And so our final answer here is 243x to the 15th power. We're given this problem right here, 216r to the 9th power, all to the 1/3 power, and we got to simplify. Well, we first want to distribute that exponent to both parts. So to do that, we have a 216, and it's going to be to the 1/3 power. Distribute that over, and we're going to do that here. Remember, separated by multiplication. Well, we have r to the 9th power, and our rules with exponents is, well, if we're raising something to another exponent, we multiply them. So we have 9 times 1/3 there. Let's keep on going. 1/3 as an exponent is the same thing as a 3rd root. So we take the 3rd root of 216 here, and multiply it by r. Well, 9 times 1/3 is really just what, 9/3? Not too hard. The third root of 216 is just 6. R to the, 9/3 power, 9 divided by 3 is 3. So we have r to the third power. And so my final answer here is just 6 times r to the third power. We're given this problem right here. 2m squared times 4m to the third power times 4m to the negative 2 power, and we got to simplify. Well, first thing is, I notice there's a coefficient in front of each one of these, 2, 4, and 4. We're multiplying them out. So I'm going to really rewrite that as, 2 times 4 times 4 here. Then we have just m's, and they're all being multiplied, and they have different exponents. So our rules tell us we take that m as a base, and since they're all being multiplied, we add the exponents. And so it kind of looks like this. 2 plus 3/2 plus a negative 2. Well, hopefully this is pretty easy for you to see. 2 times 4 times, 4 is a 32. And then we have m to our power if we have to add it up. Now let's be smart about it. We're adding a 2 and we're subtracting a 2. It comes out to be 0. So we're left with just, the 3/2. And so our final answer here is 32m to the 3/2 power. We're given this problem right here. 3b to the 1/2 power times b to the 4/3 power, and we got to simplify. Well, first things first here, right? We have the same base, b. So we multiply them together. Our rules will tell us we have to add the exponents. So the 3 stays out, and we have b to the exponent power of 1/2 plus 4/3. Not too bad, but we still have to add some fractions here. So if we find a common base, or denominator, 3b, 1/2 is the same as 3/6, and 4/3 is the same as 8/6. And they now have the same denominator, so we can add them together. We have 3b, and 3 plus 8 is our 11. So we have 11 over, keep the denominator to be 6. And pretty easy, our final answer here is now 3b to the 11/6 power. We're given this problem right here. P to the 3/2 power, all to the negative 2 power, and we got to simplify. Well, we know with our negative exponent, it's the same thing as 1 over whatever's in the inside to a positive exponent. So this is the same thing as 1 over p to the 3/2 power, all to the positive 2 power. Okay? Now our rules with these exponents is that we have to multiply the 2 by the 3/2. So keep on going. We have 1 over p to the 3/2 times 2 here. Not too bad. Well, 3/2 times 2, what does that come out to be? So we have 1 over p, 3/2 times 2, well, the 2's cancel, and we're left with just a 3. And so our final answer here is actually just 1 over p to the 3rd power. We're given this problem right here. A to the 1/2 power, all to the 3/2 power, and we got to simplify this. Well, our rules here with exponents, when we raise something to another exponent, right here, exponent to another exponent, we multiply them. So we have a to the 1/2 here times 3/2. Well, what's 1/2 times 3/2? Well, that's going to be a, multiply across the top, 1 times 3 is 3, and 2 times 2 is 4. And we're actually done here. Our final answer is just a to the 3/4 power. We're given this problem right here. 2x to the negative 7/4 power over 4x to the 4/3 power, and we got to simplify. Well, first, let's go bring this negative exponent down to the denominator. So we have 2 stays in the numerator, we have 4 right there, x to the 4/3 power, but instead of a negative 7/4 power, we have x to the positive 7/4 power. Okay. Well, we want to have, right, we need to add these two together, right, because they're being multiplied at the same base. So let's go break some things down here. 2 and 4 is just the same as 1/2, so I put that here. And we have x to the 4/3 plus a 7/4. Well, when we're adding our exponents here, we make sure we have the same common denominator. So we have 1 over 2x, and they both can be multiplied to have a 12 in the denominator. So 4/3 is the same as 16/12, and 7/4 is the same as 21/12, right there. We add them together, and I'll put that work over here so you can see it. We have a 1 over 2x to the 37th power over 12. So 16 plus 21 is the 37th power. Now here's where it gets a little tricky though, okay? When it gets tricky here, we want to separate this out a little bit now. So we have 2 times, well, x to the 36th power over 12, and then we have x to the 1/12th power. And this is a little tricky here, because what I'm going to try to do is, we know that 36 over 12 will simplify pretty easily. And we're trying to get no fraction in the denominator for the exponent. Well, rewriting this is bring the 1/12, x to the 1/12 back to the numerator. So we have x to the negative 1/12 power up top. And the denominator is actually pretty easy. 2x, and 36 divided by 12 is 3. But now I have an issue. I don't want a negative exponent. So I'm going to multiply this whole thing by x to the first over x to the first power. What happens here? Well, in doing so, our numerator, remember, we're multiplying the same base, we add the exponents. We have x to the negative 1/12 plus 1. Denominator, same thing, we add the exponents, so we have 2 to the x to the 3 plus 1. And now it's a little easier. Keep going. Right here, we have x, finishing it out here. Negative 1/12 plus 1 is a positive 11/12. And in the denominator, we have 2x, and 3 plus 1 is 4. And so our final answer here is just x to the 12th power over 2x to the 4th power. We're given this problem right here, 4x squared over 2x to the 1/2 power, and we got to simplify. Well, 4 divided by 2, that's pretty easy, right? That's just a 2. So we can leave that here, there's a 2 there. And then we have our exponents of the same base. We subtract the exponents, right? So we have x to the 2 minus a 1/2 power. Not too bad. 4/2 becomes a 2, and we have x to the 2 minus 1/2 power. Keep on going. Well, we have 2x, let's find the same base here. 2 is the same thing as 4/2 minus 1/2, and that's actually pretty easy to simplify. 2x, 4/2 minus 1/2 is a 3/2. And so our final answer here is just 2x to the 3/2 power. We're given this problem right here. 3x to the negative 1/2 power times 3x to the 1/2 power times y to the negative 1/3 power all over 3y to the negative 7/4 power. And we got to simplify. Let's rewrite some of the stuff and reorganize it and do what we can. Put the coefficients out front, and we have 3 times 3. Then, with the same base, we have x and x here. Our rules say we have to add the exponents. So we have a negative 1/2 plus a positive 1/2. And then we just have our y to the negative 1/3 staying there. Then from there, the denominator really doesn't do anything. So we have 3 here, and we have y to the negative 7/4 power. But we can simplify this a little more. 3 times 3 is 9, and then x to the negative 1/2 power plus 1/2, that's just x to the 0 power. From there, we have a y to the negative 1/3, and let's go bring this y to the numerator. That's going to be y then to a positive 7/4 power. And that's going to be all over that 3 that's left over. Okay, keep on going. Well, 9 divided by 3 is just a 3, and we no longer need a denominator here. I'll put that like this. Then we have, well, x to the 0 power is just 1, don't need to write that anymore. And now we have y to the negative 1/3 power and 7/4. But we have to add the fractions, let's find a common denominator. And then negative 1/3 is the same as negative 4/12. And we're adding that to a positive 21/12. Okay, not too bad to simplify here. Keep on going. 3 stays right here, and we add them out. Negative 4 plus 21 is 17. So we have 3y to the 17th power over 12, and that is our final answer. We're given this problem right here. 3y to the 1/4 power over, so 3x to the negative 2/3 power, y to the 3/2 power, times 3y to the 1/2 power. And we gotta simplify. This is quite the doozy. So, the numerator we're gonna keep the same, 3 y to the 1/4 power, but what I'm going to do is I'm going to bring this x to the numerator. Negative 2/3, x to negative 2/3 is the same in the denominator as x to the positive 2/3 in the numerator. Okay? Reordering this out a little, let's put the coefficients 3 and 4. This is right here, 4 times 3. And then we have y to the 3/2 times y to the 1/2. Well, we add the exponents there. So y to the 3/2 plus 1/2. Okay? So now let's keep trying to simplify here. Not too shabby though. First thing, I have 3 and a 3. I'm going to cancel that out. Not too bad. Then let's go add our denominator here. So we have a 4, and we have y, well 3/2 plus 1/2 is the second power. So we have 4y to the second power. Okay? Our numerator here, well, we just have y to the 1/4 power. So we have y to the 1/4 power here, and then we have x to the 2/3 power. Like so. Okay? Now, sometimes people like to write x first, so I could rewrite this and have, well, x to the 2/3 power, and we have y to the 1/4 power. And that's all over 4y, well, squared. And so our final answer here is just x to the 2/3 power times y to the 1/4 power all over 4y squared. We're given this problem right here. M times m to the negative 2 power times n to the 5/3 power all squared. And we gotta simplify. Well, first thing is I'm gonna apply this squared to each part being multiplied inside of our parenthesis. So that's gonna be m squared times, well, remember we multiply our exponents here, so negative 2 times 2 is a negative 4. And the same thing here, multiply n to the, well, 5 times 2 over 3. Keep on simplifying here, okay? M to the negative 4 goes to the denominator, so we have m squared over m to the 4th, and then we have n here being multiplied, and 5 times 2 is 10. So we have 10 over 3 here. Well, let's go simplify. M squared divided by m to the 4th, that cancels out, and we just have a squared here in the denominator. And so we have n to the 10/3 power in the numerator, m squared in the denominator. And so our final answer here, can't really simplify anymore here, is n to the 10/3 over m squared. We're given this problem right here, a to the negative 1 power, b to the 1/3 power, times a to the negative 4/3 power times b squared, all to the second power. And we gotta simplify. Well, first thing I'm gonna do here is distribute the second power really being multiplied to each one of the exponents inside here. So we have a to the negative 1 times 2, times b to the 1/3 times 2, times a to the negative 4/3 times 2, and then we have b to the second power times 2. Okay. Well, now let's go simplify where we can. This becomes a to the negative 2 power. We have b to the, well, 2/3 power, a to the negative 8/3 power, and b, well, to the 4th power. Well, we have the same bases of a and then some b's, so we're going to combine them together. And we have the same base, and they're all being multiplied. Remember that. We add the exponents. So we have a to the negative 2 plus the negative 8/3 here. And then we have b to the 2/3 power plus 4. Well, let's go simplify this using our fractions. Finding a common denominator, we have a now to the negative 6/3 power plus a negative 8 to the 8/3 power. And same thing with b, 2/3 plus, well, 12/3. Now from there, let's keep on simplifying. 6/3 plus, or negative 6/3 plus a negative 8/3 is a to negative 14/3. And b here as well, 2/3 plus 12/3 again is a positive 14/3. Alright, this is where it gets kind of tricky. I'm going to kind of show you breaking down what this really can be. A to the negative 14/3 is a to the negative 15/3 times a to the positive 1/3. Remember, if we add the exponents, that'll get us negative 14/3. And we multiply by b to be the 14/3. And now this is the tricky part. I'm going to fit it up here. Okay. A to the negative 15 thirds goes down to the denominator, so we have a to the positive 1/3 here, b to the 14 thirds, and we have over a to the positive 15 thirds. Well, 15 divided by 3 is 5. So we have a to the 1/3 times b to the 14 thirds all over a to the 5th power, and that is our final answer. We're given this problem right here, x to the 1/2 power times y to the negative 2 power over yx to the negative 7/4 power, and all that is to the 4th power, and we gotta simplify. The first thing I'm going to do is, well, that 4th power means it has to be multiplied to the exponent of every single one in here. So what happens here? We have x to the 1/2 times the 4, y to the negative 2 times the 4, and take your time writing this out. Y to the 4th power, and then x to the negative 7/4 power times 4. Now comes the fun part. Let's go. Well, 1/2 times 4 is easy as 2. So we have x to the 2nd power. Y to the negative 2 times 4 is, well, y to the negative 8 over, well, y to the 4th stays there. And then negative 7/4 times 4 is just x to the negative 7. So this isn't too bad now. Well, we don't want negatives in the denominator, or really the numerator, or negative exponents, so we've swapped that. Go down here, x squared, bring this x to the positive 7th power in the numerator, and we bring down the, well, remember, we're swapping this, y to the positive 8th power. Now from here, well, you know our rules, we add the exponents. So we have x to the 2 plus 7 here, and y to the 4 plus 8. Not too bad. So our final answer, if I write it out here, is just x to the 2 plus 7 is a 9, and 4 plus 8 is 12, so we have y to the 12th. And so our final answer is x to the 9th over y to the 12th power. We're given this problem right here, x to the 3rd, y squared, all to the 3/2 power, divided by x to the negative 1 times y to the negative 2/3, all to the 1/4 power, and we gotta simplify. Well, first thing I want to do is, let's multiply these exponents within it, like we're supposed to. So we have x to lost my spot here, x to the 3 times 3/2 times y to the 2 times 3/2 over x to the negative 1 times 1/4 times y to the negative 2/3 times 1/4. So now let's go simplify this. 3 times 3/2 with the exponents there, keep losing my spot, is a 9/2. So we have x to the 9/2 here. 2 times 3/2 comes out to be, well, the 2's cancel, right? And we have y to the 3rd power. Denominator once, well, we have x now to the negative 1/4 power, and then we have y negative 2/3 times 1/4 is a negative 2/12. All right. Well, both, luckily for us, numbers or parts in the denominator have a negative exponent, which means we can raise them to the numerator and make them a positive exponent. So let's go do that right here. So we have x to the, well, 9/2, okay? And then we bring the positive, or the negative 1/4 power, because the numerator is x to the positive 1/4 power, all being multiplied. Then we have y to the 3rd power, do the same thing with the second part here. We have, well, y to the positive 2/12 power, okay? Now we need to, well, simplify this where we can. We want to find a common denominator. We're adding the fractions, so when we add them together, 9/2 and 1/4 is the same thing as 18/4 plus 1/4, like that. Remember, we're adding the exponents. And then y, we're doing the same thing. 3 is the same thing as 36 over 12, and, well, 2 over 12 saves there. And we're not multiplying, sorry, we're adding those exponents. Keep simplifying here. And we have, well, x to the, add the exponents, 19 over 4. And then we have y, 36 over 12, plus 2/12 is a 19 over, well, 6. It simplifies to be 19, or 30, well, let's do that. 38, don't skip steps, 38 over 12, right? And then that simplifies. We have x to the 19/4. Simplify that out, and we have a y to the 19/6. And so our final answer here, if you can see it, is x to the 19/4 times y to the 19/6 power. We're given this problem right here, x to the -1/2 power, y squared, all to the -5/4 power, over x squared times y to the 1/2 power, and we gotta simplify. Well, first thing is let's distribute this exponent, and we do that by multiplication. So we have x to the -1/2 power times the -5/4 power times y squared times the -5/4 power, all over x squared y to the 1/2 power. All right, let's go multiply that out. -1/2 times the -5/4 is a positive 5/8. So we have x to the 5/8 power. 2 times -5/4 is y to the -10/4 power. And the denominator, well, it just stays the same for the moment. X squared, y to the 1/2. Now from there, I'm going to bring my negative exponent down to the denominator. So to do that, put it right here. We have x to the 5/8 power over x squared, y to the 1/2 power, and we're bringing down that y to the now positive 10/4 power, but it's in the denominator. Okay. Well, what do you know about our rules? When we have the same base, we add the exponents. So again, x to the 5/8 stays in the numerator. We have x squared in the denominator still. Well, we want to add the exponents here. So we have y, and we have the same base. So 1/2 is a 2/4 plus a 10/4, like so. Adding the same base, all these little steps. That's one thing. Oh, I got a 5 ahead of myself here. Should be an x. That's one thing that's difficult about doing this, is having fraction with exponents. It's a lot of work just to deal with those, adding the exponents. So we have x to the 5/8 here over x squared, and y to the, we add the exponents, and 2/4 plus 10/4 is a 12/4. But we're not done, almost there. Let's go simplify that exponent right here. So we have x to the 5/8 stays here in the numerator. The denominator, we have x squared, and then, well, y to 12 to the 4th power is the same thing as, well, to the 3rd power. So we have y to the 3rd power here. That's, oh man, that's a bad looking y. Sorry about that. Hope you feel, if you forgive me, let me know. If not, well, whatever. Y to the 3rd power. And so after all of that, our final answer is x to the 5/8 power over x squared, y to the 3rd power. We're given this problem right here, x to the -1/2 power, y to the 4th power, all to the 1/4 power, all over x to the 2/3 power, y to the 3/2 power, times x to the -3/2 power, y to the 1/2 power. And we got to simplify. All right, let's get to work. We need to distribute this 1/4 power to both parts in our exponents. So we have x to the, well, -1/2 power times that 1/4. Remember, we multiply the exponents here, times y to the 4 times the 1/4 power. The denominator here, I'm going to combine my like bases. I have x and x here. So when we combine them, remember it's all we multiply, we add the exponents. So we have 2 over 3 plus a -3/2. Same thing with the y's. Y here, we have 3/2, and then we're going to add the other 1/2, like that, by combining them there. Okay? So now let's go simplify this numerator. -1/2 times 1/4, we have x to the -1/8, and 4 times, well, 4, or 1/4, is just, well, 4/4, which is y to the 1st power. Denominator, we need to find a common denominator with our fractions. So we have x now to the 4/6 minus, same as plus a negative, 9/6, and then y 3/2 plus 1/2 is already there. That's a 4/2. Okay. Simplify a little more. We have x to the -1/2, sorry, 1/8, 1/8 power, y over 4/6 minus 9/6 is a -5/6. So we have x to the -5/6 here, and 4/2 is the same thing as 2, y squared. All right. Now that squared, though, we can get rid of that y. Cancel each other out, make it easier on ourselves here. Okay? Now I'm going to bring this negative exponent, x to the negative 5/6, to the numerator. So doing that here, we have x to the negative 1/8 times x to the positive 5/6. Now that the numerator, and our denominator still has a y in it, just one of them. From there, we know we have to add our exponents. Okay? So we have x to the negative 1/8, right? Plus, that's 1/8, not 1/2. I keep doing that. 1/8 plus a 5/6 exponent over y. Finding a common denominator here is the same thing as saying x to the 20 over 24. Oops, sorry. Flip my order around. Do my positive number first. It's going to be negative. We have x negative 1/8 is a negative 3 over 24. And we're adding there a positive 20 over 24 for the 5/6 power over y. Combining that together, 20 minus a 3 is a 17. So we have a x to the 17 over 24 power. And that is going to be all over a y. Oh my goodness. This whole problem, I've been putting the wrong thing. I say one thing, put the other. That's a y right there. Either way, though, I finally got there. I know, sometimes it's hard. And our final answer here is just x to the 17 over 24th power over y. I hope this video was helpful for you. And if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.